We all have studied some basic calculus where we have observed that e to the x can actually be written as 1 plus x square by 2 factorial plus so on. This is derived from Taylor series. Technicalities aside, you just need to know that e to the x is so much. If e to the x is so much, what is e to the minus x? You will simply get this. In place of x, you have minus x. And x square will simply be as it is because when you put x equals minus x, x square will continue to be x square. But then x cube becomes minus x cube and so on. So e to the minus x will be 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus x to the 4 by 4 factorial minus x to the 5 by 5 factorial and so on. You have a minus sign in front of x to the I if I is odd and plus sign if I is even. As simple as that. Now look at this. Let me do e to the x plus e to the minus x by 2. You see, these things get cancelled like this. And you will get 2 times 1 plus x square by 2 x square by 2 factorial plus x to the 4 by 4 factorial plus x to the 6 by 6 factorial and so on. Only the even terms you will get if you add e to the x and e to the minus x. So 2 can come to the left hand side in the denominator and this becomes e to the x plus e to the minus x by 2, which is equal to so much. Let us box this for future reference. Similarly, you can observe that e to the x minus e to the minus x by 2 is actually equal to x plus x cube by 3 factorial plus x to the 5 by 5 factorial and so on. Why are we even seeing this? How will this help us in counting? That's the surprising part in discrete math, where something very unrelated sometimes helps us in counting something that's very advanced, a question. And here goes your question. The question is, there are 32 people standing with red, blue, green, yellow colored shirts. Their entire wear is red, blue, yellow and green. 8 people are wearing red, 8 people are wearing blue, 8 people are wearing green and 8 are wearing yellow, totaling to 32. Do you see all of them in a sequence, standing in a line? Now, I want to pick some 8 people from here, some 8 people and make them stand. And these 8 people in a particular combination of colors signify something. Okay, maybe it's some sort of a coding of soldiers standing in the border, or it could be some kind of a signal that you may want to give to your neighboring city, or maybe you're going in a ship and you are hoisting flag colors like this in a sequence to send out a message. It can be anything, whatever. But the question here is simply this: in how many ways can you pick 8 flags with this 8 plus 8 plus 8 plus 8 of red, blue, green and yellow respectively and create a signal? How many such signals can you create is the question. And surprisingly, we will see how we can use this e to the x, e to the minus x, e to the x plus e to the minus x by 2, etc. in solving this problem. A key point, a good advice: please understand the problem carefully before understanding the solution. So now let's look at the solution for this question.